Share my screen. Are you able to see my screen?
Yes, I can see it.
Let me make a present. No. Okay. So today I will give an introduction to the DOE demonstration project. Before I begin my presentation, let me first introduce Poland General Electric. Poland General Electric is a utility company in the Northwest. We have generation, transmission, and distribution networks. I think what makes us stand out is our focus on the technology. Every year, we invest heavily in high-end technology projects. We even have our own math scientists helping us on the project and using AI to analyze data. And we're not just about business. We work closely with the scientific communities, partnering with universities and the research institute. We are fully engaged in the Department of Energy's projects to solve problems like the smart grid and the control how the electricity is used. And then let me briefly introduce the background of this DOE project. The U.S. Department of Energy has a funding program about $17 million called Solar and Wind Grid Service and the Reliability Demonstration. The goal is to prove that the power system relying on solar, wind, and battery storage can be dependable. So this program was announced in August 2022, and in May, you guys still see this thing? If I should remove from other screen.
So I can see your screen. Yeah.
You can see my screen. Okay.
Yeah.
And in the May 2023, 8 projects were selected. We are one of them, with 4.5 million from federal government and about 6 million cost share, making it about $10 million project. So these projects aim to figure out how to keep grid voltage and frequency stable, which is crucial for a smoothly running power grid. And so the funding supports the development of controls and the method to demonstrate that a grid powered by inverter-based resources can use service from wind and solar. Overall, the program aims to enhance the reliability of the energy systems as more solar and wind energy is integrated into the grid. So the ultimate target is to achieve a carbon-free electricity sector by 2035. And who we are and why we are here, I want to introduce us. So look at the screen and you will see our team, a group of people who have been partners for years. We have worked together on many things before. We all wanted to figure out how to keep the system stable, especially as more and more renewable energy resources come into play. Our journey began long before we noticed the problem with the WAC system, even before the renewable were all the range. Take the Wyoming oscillation for 2012, for example, an unstable situation caused by the high penetration of renewable energy. That was the first time we recognized the impact of the renewable on the system. And then for the recent activities, we work together, such as our analysis of the frequency response of the WAC system last year. We also recognize that the system could become unstable if we stick with the current technology. These are just a few examples of how we collaborate on system analysis, planning, operations, and model development. Now, here is the exciting part. This project we are discussing today, it is not just a theoretical. I think it's more realistic. Rather, it's about translating our idea into the real life solutions. I think this project gives us an opportunity to validate the theoretical work we have been doing for years. That is what brings our team all together. So team members and roles for PGE, our team will lead the entire field demonstration. Many departments of PGE will be involved in this project. And then GE plays a crucial role in the demonstration project. They will show the latest technology. This includes the demonstration of grid forming technology for Type 3 wind turbines and also batteries, along with the hybrid plant controllers to integrate grid forming and grid following control in a plant with a coexisting wind, solar, and battery system. GE will also assist in developing a generic model. And Nextero, which is a co-owner of the demonstration site, they will work closely with PGE to conduct engineering studies, obtain approval and the permit, design the grid forming grid service demonstration, install the new grid forming battery, upgrade the grid forming control for wind converter and the turbines, upgrade the hybrid plant control, install the data acquisition system, as well as assist the GE upgrade the power plant controller. And BPA, who is the regional transmission provider and the operator, maintains closely linked the transmission system with PGEs. So their team consisting of planners, operation engineers, and PMU data management engineers they will collaborate with us on year-round operation and the planning effort. They will assist in setting up all kinds of different operating environments and collecting data through their PMU network in the Northwest during the demonstration. And also they will collaborating on the pre-demonstration studies. PN also involved in developing a grid forming generic model and contributing to a large system simulation studies. PNL's two-based grid forming generic model was approved recently by WAC and has been utilized for WAC system analysis. They will collaborate with GE and the WAC modeling and validation subcommittee to create a generic grid forming model for Type 3 turbines. Those will prepared for planners in the system analysis. UT Austin's role is to investigate the grid forming for DC coupled PV battery energy storage system in the university's lab. Since upgrading the DC coupled PV and the battery storage to grid forming in this demonstration set is not currently feasible. So the UT Austin team will develop a grid forming control strategy for the DC coupled PV and battery system and test it in the university's lab. Portland State University, they will provide a internship for this project. We plan to hire 6 interns to help for this project. Demonstration site. We picked the Wheatridge plant. Wheatridge plant is about 6 hours east of Portland, Oregon. And we picked this plant as a demonstration site because it is the first place that combines wind, solar, and battery storage all together. Plus, it's pretty big. Wheatridge fared up last year, and we think using this mixed up power plant for our demonstration means it can do way more than those one-trick pony power plants. If this demonstration goes well, we think we are thinking it could be the model for how we run things in the future, and we hope to pick up some good things as a utility. And other utilities may want to copy us and learn some cool stuff too. And on the screen, this is the one line diagram, and there is 2 station transformers split this power plant by 2 parts. On the left, that is a part of the GE wind turbine and DC coupled PV and battery. On the right hand, that is pure GE type 3 wind farm, and our plan to install a new grid forming battery storage and upgrade some grid forming turbines to grid forming. In addition, we will add a new hybrid power plant controller in the substation. For the technical objectives and the approach grid services for demonstration, on the right, you will find the examples of the grid service demonstration we will perform. These include managing frequency, controlling active power, regulating voltage, and handling various aspects of grid operation. These services are showcased at the control level. They are generally, we know there are just 2 types of grid services, like economic and the controls. But our project specifically focus on the control service because ensuring the reliability and the stability of the future grid is the key. In our demonstration, we will use a combination of grid forming and grid following technology to show how our system responds to change in frequency and voltage. This will also involve a hybrid control demonstration, incorporating wind, solar, and battery system. To achieve this, we will be upgrading some turbines to grid forming controls and enhancing plant level controllers and installing grid forming batteries. So demonstration timeline. This is a 3 years project. We split it by 2 budget periods. The demonstration of grid service preliminarily occurs in budget period 2. Before that, we think we must make some necessary preparations. So these preparations revolve around a pre-demonstration study. So this study aims to identify the internal and external interactions of the plant and then provide a summary conclusion on which traditional and grid forming related grid service are technically feasible for the demonstration. We think achieve this, we need to develop the detailed models and then fine-tune controllers parameters during the preparation phase of the grid service demonstration, other studies such as initial cost benefit analysis and consideration for the site access permit and approvals also need to be conducted. And moving on to the budget period 2, we need to complete the upgrades for the turbines and the controllers, install batteries, and set up the data acquisition system before we can demonstrate grid services. Specifically focusing on the frequency and voltage response. Another key task in this phase is to create a generic models for the positive sequence simulation. This model is essential for the interconnection-wide study because it is a public accessible with the detailed document that transmission system planner need and can use for their analysis. After the project concludes, we will conduct detailed data analysis, write report, and calibrate the model used. From these slides to the following, I will introduce some key tasks in detail. So this task is a key step towards the development of and the validation of grid forming control technology for wind turbines and battery energy storage system. The primary objective of this task is to identify the essential feature and the performance metrics required for grid forming resources. This will also involve extensive research and development to come up with a information sharing protocol, conducting preliminary and comprehensive validation studies, and performing a grid forming reliability and risk assessment. To achieve this goal, we will collaborate and work together to assess the area of additional risk and determine the necessary resources which is required for the grid forming upgrade. We think the existing UNIFI consortium grid forming specifications will be used as a reference when developing performance metrics. The ultimate goal of this task is to provide a estimation of the reasonable scale for the grid forming demonstration. With the successful development and validation of grid forming technology, wind turbines and battery energy storage system improve the grid forming capabilities can ensure a stable and reliable power supply. For this task, finalize the grid forming control and prepare set for the grid forming demonstration. The first one is we will adjust the grid forming control based on the earlier validation studies and the project team agreement. The second one is conduct the internal review for grid forming control design. We will review and verify the technical readiness of grid forming controls for each resource type to be demonstrated. This will include the wind control, battery energy storage control, and hybrid plant control. This may include multiple design reviews for new technologies. And the third one is collaborated to necessary approval and the permit for plant modification. We will collaborate to get the necessary approval and the permit for the plant modification, commissioning and the testing in advance of the demonstration. We will plan site modifications and design engineering solution based on initial assessment to install additional equipment and a hybrid power plant controller. The last one is design grid service demonstration. We will design the grid service demo, including timeline risk mitigations and alternative plans based on possible outcome. For this task, model and the hardware in loop test bed development for hybrid plant. The first one, development of hardware in loop test bed and the preliminary software in the loop and the hardware in the loop testing. We will develop a hardware in loop test bed with real OEM hardware controllers for grid following battery storage system, grid forming battery energy storage system, grid following wind and hybrid plant control, grid forming wind control, grid forming battery energy storage system control, and hybrid plant control. Those will be validated using software in the loop and hardware in the loop testing. And second one, develop realistic models for grid forming wind, battery, and hybrid plant control. We will embed real control code suitable for simulation in the EMT domain and positive sequence domain. This model will be used for validation studies. And the third one, hybrid plant network EMT model development. For this, we will develop EMT models for hybrid plant using network data collected. And the next one, generic EMT model development. We will develop a generic EMT model for the grid forming type 3 wind turbines and the battery storage based on a literature review. And then we will perform EMT simulation studies of the hybrid plant and development of DC coupled grid forming inverter. We will develop both EMT and hardware in the loop models for DC coupled PV and battery system. For the site, for the grid forming resource and plant control convincingly. So number one, we will install a battery that can be configured for grid following and grid forming mode. After grid following mode commissioning, the battery will be reconfigured for grid forming mode and retested. And second, we will upgrade a portion of the existing grid following wind turbines to grid forming control, including the converter and turbine control. Our plan is to do that at least 5 turbines. We'll also support the commissioning and the testing of the upgraded control to validate performance. And then we will upgrade hybrid plant control to accommodate the grid forming and the grid following resources and mix your plants with varying grid following and the grid forming resource. And the set modification, we will complete the installation of the equipment, the devices and monitor equipment which to be used during the demonstration, including the power meters and the portable power system monitoring devices. Those equipment will be installed near the grid forming and grid following resources, and also at the point of interconnection, as well as the substation, and the CTs and PTs will be installed to support the hybrid plant control hardware. And then they will make necessary set modification, including the civil works, cable laying, and the equipment installation. Those two implement the grid forming battery and the isolate the upgraded part of the plant. And then modification will be made to the plant control for compatibility with the grid forming capable hybrid plant control. And for the modeling and the simulation and hardware in loop validation and the system level simulation studies. For this task, we plan to test and validate reconfigure within the batteries and the hybrid plant controls using software in the loop and hardware in the loop. They will validate specify the modifications. We will collaborate to develop a generic topological sequence model for the grid forming type 3 wind turbines. We will study grid forming and grid forming inverters provide grid services, and we will perform hardware in loop experimental testing of DC coupled PV and the battery grid forming inverters. So finally, we got with all those preparation, and then they at the budget period 2, we will finally got the demonstration. So for the frequency regulation, during the demonstration, we will monitor for grid frequency event. So that's our plan, and we will compare the performance of the different resources during this event, including the wind power and battery storage. We will investigate the active power response performance for different frequency control settings applied by both grid following and grid forming resources. The investigation will also include emerging grid forming services such as static inertia and damping. For the voltage regulation, we will compare the performance of different technology. We're monitoring the for the voltage event in the grid, the impact of various voltage control features and the parameter settings will be investigated. And then the hybrid plant controller performance. We will study how well the hybrid plant controls works together to respond to the grid events, compare with the neighboring plant that only has one type of control mode. For additional grid forming grid service demonstration, we will monitor phase jump events and compare grid following and grid forming IBR's performance. Black start and islanded operation of grid forming inverter-based resources will be tested based on the budget period 1 pre-demonstration studies. And for the data collection, we will collect Polynomial wave and PMU data for analysis, and the review and adjust the control parameters and modes. For the preliminary result analysis reporting, we will analyze the demonstration result and then prepare a report with the grid-forming grid service findings, and then compare grid forming with grid forming performance for wind and battery using the grid forming metrics we defined in the beginning. The industry impact, we think this the DOE project, this demonstration project, will make a big impact on the industry. We know the faster growth of renewable energy today, if we're waiting for the government to set the standards and then make utility follow, then maybe too slow to encourage new technology and effectively deal with reliability issues. The potential effect of this project, I think on the industry is huge. Our main goal is to fully understand the strength and the weakness of the two technology involved. And I think by going through this demonstration project, this understanding will boost our confidence in offering a many different grid services. And it is also a key to establish a good communication channels between the utility and original equipment manufacturers. And I think this will help OEMs to understand the real needs of the power system operations. Based on our experience in developing the Wang generic model, we have successfully set up these channels with OEMs. It let them know our needs, and in return, we have their support in creating the successful models. And I think by doing this project, we can create the same path. And at the same time, I think this project can help utility to think about including the grid forming capabilities in our interconnection requirements. This underlines our commitments to advancing technology, meeting the changing needs of the power system. I'll be involved in many interconnection requires meetings, cluster studies, and in the next 5 to 8 years, there are probably thousands of megawatts renewables will be installed in our system, and our cluster study will form soon. And so that is really important for us to create some kind of a requirement to avoid future problem with small, I will say with less grid forming technology. And I think that's about my presentation. From here, I can take any comments and suggestions and questions.
Okay, thank you very much, Song, for the